about parallelograms. There's three theorems that give us information about properties about parallelograms we want to talk about, and I don't have all these in type here, text handwritten. So I'll read through them with you, and then I'll give you time to copy them down. Theorem 1 is that the opposite sides of parallelograms are congruent. The second theorem says opposite angles of parallelograms are congruent. And the third one says diagonals of a parallelogram bisect each other. The three properties about parallelograms that come in the form of theorems. If we wrote these as conditionals, we would say something like, if a quadrilateral is a parallelogram, then opposite sides will be congruent, or are congruent. It would say, if a quadrilateral is a parallelogram, then opposite angles are congruent. And it would say, if a quadrilateral is a parallelogram, then the diagonals bisect each other. Okay? The reason I'm pointing this out is lesson 6.3 and 6.2 look very much the same. The difference is there's three theorems given to you in lesson 6.3 that are the converses of these. They say if opposite sides of a quadrilateral are congruent, then it's a parallelogram. If opposite angles of a quadrilateral are congruent, then it's a parallelogram. If the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So in other words, they're just taking these three theorems and turning them around. These three are saying, if I know it's a parallelogram, then all three of these things are true. The others are saying, if any one of these things are true in a quadrilateral, then that must be a parallelogram. I'm pointing this out because we're not going to take time to do both lessons 6.2 and 6.3. We're going to talk about 6.3 today a little bit as it refers to the information I'm giving you today. But we're not going to take a separate day to deal with that. Okay? And then there's a fourth one here. Oh, sorry. So what this theorem is saying, here I have three lines that are all marked parallel. And these marks right here mean that those two segments are what? Congruent. Okay? That means they're congruent. So what this is saying is if these three parallel lines, 1, 2, and 3, cut this transversal into equal pieces, and that means it's going to cut every transversal into equal pieces. So if this was A, B, and C, then that would mean that AB is equal to BC. And so if I knew this was 2x plus 2 and this is 3x minus 6, then I could solve for x by doing what? Louder? Okay, so what do I write? 3x minus 6 what? Equals 2x plus 2. So if I subtract 2x from both sides, I get 1x minus 6 equals 2, and add 6 to both sides, x is equal to 8. And if they asked me to find BC or AB, then I would take that 8 and I'd plug it back in. 2 times 8 plus 2, that's 16, plus 2 is 18. Or 3 times 8 minus 6, 24 minus 6 is 18. Either way, I would get those two sides equal to 18. Okay? Any questions on that? All right? So consecutive angles says two angles in a polygon that share a common side. So can someone name a pair in this octagon here, a pair of consecutive angles? Any pair of consecutive angles here? Any of these 8 angles that share a common side?
2 and 3.
2 and 3. 2 and 3 share this side, don't they? Oh, I'm sorry. 2 and 3 you said. 2 and 3 share this side, right? This is angle 2, and this is angle 3, and they both share this side right here. Okay? Are there any other consecutive angles up here? Katie?
1 and 7.
1 and 7. Well, let's look at that. Oh, no. So 1 is this angle, and 7 is this angle. Do they share a side?
No, so it's
1 and what?
1 and 8.
1 and 8. Okay? Again, 1 is this angle, and 8 is this angle, and so yeah, they share this side. So I would agree with that. So 1 and 8. How about any others? 7 and 6. Any others? 5 and 4. Any others? Say again? 4 and 3. Can anybody give me a different way of describing to maybe your classmate? How would you say it to them to say, if they say, I don't understand what consecutive angles are, what would you say to them?
They're next to each other.
They're next to each other? Okay. Hunter, you're saying something. What is it?
Is it adjacent angles too?
Adjacent? Yeah. Adjacent, they share a side. Okay. The problem with adjacent is they also share the vertex. So adjacent would be angles like this, where they share this common side, but they also share that vertex. Where these don't share a vertex, they just share a side. So you might say that to a classmate to help them understand where to look, but I just want to make sure you understand the difference between adjacent and consecutive. Okay? Emily, you were saying something, but I was still in conversation, so I couldn't hear you. Almost adjacent? Yeah. Yeah. So I like to say something like they're next to each other. They're in order, the next one in the order as you go around the polygon, right? So as you go around the polygon, there are two angles that are next to each other, okay? Consecutive. All right, so if I'm told ABCD is a parallelogram, and I want to find CD, what relationship do I know is true if I know this is a parallelogram? Katie?
AB is congruent to CD.
It is, because why?
The parallel. They're
Um,
congruent.
Okay, but why are they congruent though? I mean, how'd you know they were congruent?
The definition of
It's something we just got today, right? One of the theorems says what?
opposite sides of parallelograms are congruent.
That's right. So that's how you knew that. So if someone said, how'd you know that, Katie? You say, because there's a theorem that says opposite sides of parallelogram are congruent. Okay? That's how you say it. So she told me that AB is congruent to CD, so since AB, segment AB, she meant to say, since she used congruent, the segment CD, or if she said AB equals CD, that'd be the same thing. And so, what would I write then to solve for CD? Someone other than Katie.
3x plus 4 equals 5x minus 12.
3x plus 4 equals 5x minus 12. Okay? So, Megan, what would I do to solve this?
Subtract 3x from both sides.
So, do you agree I get 2x over here? Equals 4 now that this is gone. And the other Megan, what would I do next to solve this?
Add 12.
Add 12 to both sides, so do you agree that's 16? And then Emily, what's the last thing I do? Divide by 2, so I get x is 8. There, am I done? No, why not, Amber? Okay, did they ask for x? No, they asked for what? CD, which is 5x minus 12. So to find the length of CD, I have to find x and then plug it in. So you're right. So 5 times 8 minus 12. What's 5 times 8? 40. 40 minus 12 is 28. Okay, so the answer is 28. All right? Now, when I'm checking your test on something like this, if you circle a whole bunch of different things, but they're only asking for one, it gets confusing to me what you think the answer is. So I would prefer you not do what I did here. And not circle this, because that's not the answer we're looking for, is it? We're looking for 28. So CD is equal to 28. Maybe you actually write equals CD. Okay? Then I know what your answer is. I'm not confused at all. All right? When you make your test easier for me to correct, then when you have mistakes on it, it's easier for me to give you some points for that. Because you're demonstrating throughout the whole test, you really are understanding what's going on. Okay? All right. What do you think I should do in this problem? Again, we have a parallelogram. We'll call it PARL. Parallelogram PARL. And we'll call this B. We have to know it's a parallelogram. What do you think, Adrian? Is it, did I say it right? You don't know? I know it's your first day, but I just gave you a rule that will help us answer this. Okay, that's all right. This is a safe zone, right? We don't laugh at each other if we say something wrong, so go ahead. Okay, so which one of our rules that we learned today, our new properties, our theorems, one of our new theorems? Opposite sides are congruent. Okay, but these aren't opposite sides, are they? These are the angles. Is this marking an angle or is it marking this? It's kind of confusing, but it's marking this little segment right here. So we're not talking about the angles either. What's the third rule that we were given? Okay, so diagonals mean if I connect opposite corners of the parallelogram, and that's what these red lines do, don't they? And so they intersect, and bisect means what? Mr. Brill, Rebecca? What does bisect mean? They go through each other at their what? At their midpoint. So they cut each other in half. Does that mean all of these are equal? If they cut each other in half, does it mean they're all equal? Pay attention here. This is an important concept. Are we saying all four of these are equal? So the question was, I've circled four numbers here. Are they all the same? Does bisect each other mean that all of them are the same? Yes or no? Silas?
Uh,
No?
uh,
No or no, I don't have an opinion.
but if,
Okay. I want your opinion. I didn't hear you. What did you say?
yeah.
Yes, you think it means they all are equal. Okay? Let me draw this picture. So these are pretty close now. If these two segments, oh, good, we're so recording. If these two segments bisect each other, does that mean this distance is equal to this distance is equal to this distance is equal to that distance?
Only the-
Doesn't mean all four of them are equal to each other, does it?
Just the opposite ones.
Yeah, just these two little short ones are equal and these two longer ones are equal, right? So bisect each other doesn't mean that all four new segments are equal. It means that the opposite ends of one segment are now going to be equal, and the opposite ends of the other segment are going to be equal. So in this case, then, let me get rid of all this. Try to clean some of this stuff up. All right, now, so what does it mean then? What can I say? What statement can I write? Ms. Linehan?
PB's congruent to RB?
PB is equal to RB. Okay, good. I like that. And you wrote it in symbolism first rather than just writing the statement. So what else is true, Rebecca?
PB is congruent to BL.
Nice. AB is equal to BL, bless you. Okay, that's exactly what that statement means. Diagonals of a parallelogram bisect each other. Meaning if this is a parallelogram, then those diagonals are going to cut each other into equal pieces. Not all four equal to each other, but opposite ends. This one equal to this one, and this one equal to this one. So now, I want to actually solve for x and y. Jesse, any idea what I could write to solve for x?
It's -6 plus x.
3x minus 6 plus x. What will that give me? What's that?
180.
180. Are these angles? No. Are we confusing these segments with rules about angles of a triangle? I'm glad, Jesse, I'm not glad that you're thinking wrong, but I'm glad you said that because that's a problem I see on the test also. People are making that mistake. When we get confused sometimes we throw in the number 180 because it's so popular in all the other things we do. So I just want you to go back to this, Jesse. Look up here, please. We said AB is equal to BL. How long is AB in this picture? What marks did they give us to tell us the length of AB?
X.
X. And how long is BL? 3x minus 6. And this says that AB is equal to BL, right? So that means what? Someone help me.
X equals 3x.
X equals 3x minus 6. Right? Now, some of you, to solve this, might say, I really don't want to move my 3x over because that's going to give me a negative number, but others are going to say, I don't want to make an extra step just to avoid a negative number. So you can either move your x over, and yours over here, and your negative 6 over here, or you can just say, let's subtract 3x from both sides. So I get negative 2x equals, what's left? Negative 6. Then divide by negative 2, And so I get x equals a positive 3. Okay? Now how would I solve for y, Allison? 2y, which is PB, right, equals y plus 12, which is RB. And so if I subtract y from both sides, I get y equals 12, right? I subtract y from over here in here. Y equals 12. So I found x and y. Put that on my desk. Any questions on how to find that information?
Roger.
Thank you, honey. Okay. Moving on then. Find the measure of angle M. Angle M is right here, isn't it? Did they tell me anything about M? No, they didn't. Okay? I'm going to pause this for a minute, and I want you in your group to discuss how you can make a connection between angle O, angle B, and how we could get back to here. Okay? All right? So I'm going to pause. You in your groups talk about that.
So,
Okay.
Angle M.
I know it looked like I was reading the paper. I was really eavesdropping. I heard some good conversation. I had some good questions. And some conversation that really wasn't about math. But, Jackson, tell us what you were saying about angles B and O.
the same side interior angles.
Okay?
So they add up
Actually,
together.
what I heard him say, if I demonstrate here, he said if we extend these out, he's saying that those angles B and O are same side interior. They're on the same side of the transversal segment BO, and they're inside the parallel lines AB and MO. Okay? So the same side interior. What's true about same side interior, Jackson?
They add up to 180.
They add up to 180. Okay? They add up to 180. But again, Jesse, I want to point out we're talking about angles here. Not a triangle this time, but they are still angles that add up to 180. So be aware of that. So these two angles aren't equal, but they add up to 180. So 3x plus 2 plus 7x plus 18 equals 180. Okay? Any other groups make that connection? Good. Good for you. So, if I solve this, how many... Hey, look. Here's another mistake I see a lot. People start subtracting 3x. What's wrong with that? They're on the same side, aren't they? What I tell a lot of kids is to draw this line under the equal sign. If they're on opposite sides, then we undo. We do the opposite to get rid of it. If they're on the same side, we do what it says. What is 3x plus 7x?
10x.
10x. What is plus 2 plus 18?
20.
Plus 20 equals 180. Now we're on opposite sides. So undo the plus 20 by
Subtract.
minusing 20 or subtracting 20. So I get 160. Actually, I'm going to move this over. And then divide, and I get x equals
16.
16. So have I solved my problem? No, I haven't. All I found was x, haven't I? I still need to make a connection from what was given to me to the measure of angle M. And I didn't hear anybody say anything about this. I did hear something, but I wasn't sure the connection was made yet. What connection do I have with the information that's given to me in angle M? Someone else in your group, Jackson, can they speak?
Yeah, B equals M.
Oh,
Is congruent to M.
because they're Y.
Because of the theorem that says opposite angles of parallelograms are congruent.
Yeah, opposite angles of parallelogram are congruent. I thought I heard Brad say that earlier. Opposite angles of quadrilateral of a parallelogram are congruent. So that means that measure angle M is 7x plus 18, isn't it?
Mm-hmm.
Measure of angle M equals 7x plus 18, and we just discovered that x is 16. So 7 16s plus 18. What is it? 4,212
112.
plus 18, 130.
Mhm.
So that's how we get that. Okay? Nice job over there. Nice job back there. You get it also? Good. Good. You did good, Dalton, with helping them through that. All right? Any other questions on this? Anybody we lose? Any step here we lost you? Okay. Let's pause a second. I'm going to record this conversation real quick. I'm going to tell you my plans. I think next week you're going to be asked to take the NWEA test again. I don't know for sure. We haven't been given a schedule yet, but I think that's what's going to happen. And that'll probably take 2 days like it did before. And all the sophomores will take it, I'm guessing, like we did before, in the morning or afternoon, and the freshmen will take it the opposite time. But anyway, I'm not positive on what's going to happen, but I do know we're going to be short of time. I do know that I don't want this hanging over our heads over Christmas break. So in my mind, we're going to test on this no later than Thursday of next week. Wait a minute, I gotta double check my calendar. Sorry, I was just wanting to make sure that I hadn't forgotten a week. There's only, next week's our last week before Christmas break. So, we're going to cover, tomorrow we're going to cover lesson 6-4. Thursday we're going to cover lesson 6-5. And Friday we're going to combine 6-6 and 6-7 together. Okay, they're not going to double things up on you, but there's little bits in 6 and little bits in 7 I want you to see, and we're going to cover that information on Friday. I will record everything and post it so if you're gone, but it's really important that you stay with us and that you're in class and that you keep up and you do these assignments as I give them to you. Don't wait until the weekend. Then on Monday, you're going to be given your review, and then depending on when testing is, the test could be any day from Tuesday to Thursday. Okay? And if there's no testing, then we'll talk about when it's going to be, because we have information that we're going to be in a crunch to get in when we come back. And so we might begin some of that before we leave, but we won't be testing on it until when we come back from break and we've had at least a week of more class. Okay? Actually, I didn't plan on taking the final test on that. It's just going to be all part of the exam. Does that make sense? Okay, so you know where we're at. And you have your assignment. The important thing is to keep up. Ask questions as we go. Don't get way behind.